All right, so in this section, we're going to quickly talk about shadow ray biasing. It's unlikely you'll need to know about this in any regular frequency, but I think it's good to understand how Redshift is handling geometry and their normals in case you do run into any issues along the way. So to start and illustrate what shadow ray biasing does, we're going to enlist the help of a trusty sphere. I'll go ahead and apply my material to it. And as you can see, Redshift is smoothly shading the surface, which initially you might attribute to the Phong tag and Phong angle, which is not untrue. However, Redshift is actually biasing the shadow rays in such a way that this geometry appears smooth. And you can see if I actually disable shadow ray biasing, we actually will see a bit of faceting here. And no matter what I do, no matter how high I set my Phong angle, it's going to appear a bit faceted. So shadow ray biasing is actually helping us kind of smooth this out by averaging and cheating the normals a little bit. So if I turn it back on, you'll see we smooth out nicely. So I'm going to flip it back off, and we're just going to add a little bit of subdivision to the surface. And as soon as we do, you'll see even with shadow ray biasing off, the normals are similar enough to show us a smooth surface. Now by default, shadow ray biasing is turned on. And you're probably thinking, well, probably on for a reason, so that my smooth surfaces don't look jacked by default. So why would I ever want to turn it off? Let's go ahead and take a look at a scenario real quick where we've got shadow ray biasing giving us an issue. So in this case, I've got an object that is casting a shadow onto our cube, and we can see it's shading it kind of weirdly, and that's because our normals on our cube here are very sparse and quite different. So as Redshift employs this shadow ray biasing, we actually get some issues in our apparent lighting. So this is actually a case where if I disable shadow ray biasing, you'll see we smooth out our normal issue there, and we're casting our shadows in a way that we would expect to see. Anyway, not a huge deal, but this could help you if you're trying to troubleshoot a model that you've bought that has some pretty jacked normals or is very low in polygon count, and you can't subdivide it because it is so low poly that it would break the mesh. Like in this case, if I were to go ahead and tessellate it, we would totally break. Anyway, thanks for checking this section out, and we'll see you in the next one.